On the smart meter, we're hitting 10 on the box. Hey everyone, in today's video we're going to be covering smart meters. There's a whole lot of misinformation online, on social media especially, and we're going to do a few experiments that I think you'll find really interesting. This video is probably going to get a lot of dislikes because people dislike smart meters. So I encourage you, if you like the information, if you like the video, take the extra time to click that like button to help offset the enormous amount of dislikes that I'm going to be getting on this one. So let's dive right into it. The first thing we're going to want to cover is basically how to read a smart meter. The traditional RF meters, the radio frequency ones, they have a digital screen instead of the dials, but those weren't smart meters. They were simply read from a distance, maybe 50 feet away. It uses the same technology as a kid's remote controlled toy car, radio frequency. There is a lot of theories about harmful RF or EMF or whatever waves. We'll look at that in a minute. But let's take a look at what we're seeing on the screen here. So this is my house. I have a solar system set up to backfeed. It is an absolutely gorgeous sunny day outside. So I'm backfeeding onto the grid right now. You see these little blocks, bottom left corner? They're gonna light up. There's one square, there's two, there's three. They're going backwards, they're going to the left. So that shows that I'm not using power. I'm actually generating enough power to feed my entire house, as well as backfeeding onto the grid, which I will receive credit for that at a 1-to-1 ratio to offset my bill, let's say later on this evening when the sun goes down. So on these meters, and of course there's different manufacturers of meters, so this may vary slightly, but the main number you want to focus on, the first one that's going to show up on your screen, not that guy, hang on here, just going through its cycle, and it should come up here now. So D1, 27,776 kilowatts. So D1 is delivered. R1 is received, 5981. So that D1, the majority of homes that don't have solar, that's what you're using for power. So I've used, 27,000 kilowatts since this meter was installed. I've had a smart meter for over a year now. That's the number that you should see on your bill. If you're concerned about the readings not being accurate, look at that number, look on your bill, make sure those numbers jive. You should also be able to see on your bill that number right there, 1015116. That is the particular meter number. In my 21 years as a power line technician, anytime there was a dispute with billing, it come up, the meter was working fine. There are of course cases where, especially in apartment buildings where there's like 50 meters on a wall, when the guy initially installed them and had to write all those numbers down, maybe he mixed one up and unit 207 was paying for you at 107 or whatever. That's an error on the installer's part. Easy fix, you swap them. All the billing will be adjusted for any overpayments. It doesn't happen often, but definitely if you do have any concerns, check that out. Check out your meter number. Make sure the meter number is that on your bill. It probably is. If it's not, give the power company a call and they'll look into it. I'm not going to go into the solar backfeed stuff a whole lot. We did cover that in a separate video, but the next number you're going to want to look at, let's flip this camera here around again. So we've got the kilowatt hours I've used, 27,000 kilowatts. 5981 I backfed into the grid. And this next number we're going to see is demand, 10.384, and receive 9.6. So that demand, it's the peak amount of power I used at any given time during the month. So at one point in the last 30 days, I was using 10 kilowatts, which isn't that high thanks to solar. And the peak power that I generated with my solar was 9 kilowatts. that you would also add what my house is using at that time. So my solar system is probably generating 13 or 14 kilowatt hours instantaneous. That number, you don't even have to worry about it. Residential customers are not built for peak demand, but we're going to cover that a little bit more towards the end of the video. What I want to cover next is the talk of fires, that smart meters are a fire hazard. First of all, this particular brand that we, as well as everyone in North America is using now, there have been no reports of any fires related to those meters. There are still issues where, yeah, you might have smoke or spark coming from your meter. It has nothing to do with the smart meter itself. Regardless of what meter was on, those fires would have still happened. We're going to explain why that is here in just a moment. Before we dive into that, this is what the back of a meter looks like. It's basically like a plug. This is the meter socket. Depending on the jurisdiction, in our area, I own this. As a homeowner, I own this meter socket. The power company owns the meter that plugs into the socket. That socket, it's not much different from a socket in your house. And the meter is not much different than a plug that goes into that socket. So this is your meter socket. The technician shows up and the meter literally plugs in. When that plugs in, there's two prongs that squeeze on these, same as a smart meter. It plugs in, but it's much more rugged. These plugs are designed for 15 amps. This guy is designed for 200 amps. Every bit of power that's going through your home is passing through those prongs, which literally have two pieces of metal squeezing on it. I'm sure you've all seen pictures online, maybe even at your own home, where a plug starts to fail and it'll burn, turn black there, or maybe when you plug something in, it's not secure, it starts to fall out. That's just those prongs getting weak. So when those prongs are weak, you're getting a bad connection. You might have a toaster or microwave, whatever, plugged in, drawing, let's say, 12 amps. That heats up, there's a bad connection, so it creates resistance, which causes heat. That's gonna start to melt this guy. That being said, guys, when those small, I wouldn't even call them fires, happen, it's not because a plugged in smart device is faulty, or it's not a big conspiracy theory. It's just bad connection. So what we've got here is essentially the same as a meter socket in your house, except this guy is an adapter. It's an old A-base style. I did have a video on what these A-base styles are. But the guts in here, basically the two plugs, same thing as what's on your home. This meter literally plugs into those prongs in the exact same way as how a plug works. Now remember, those connections, that's feeding everything in your house. If you've got 15 baseboard heaters, you got a great big 3.5, 4 ton heat pump, whatever it is, all that power is flowing through that. It wouldn't make sense to have a bolt-on connection, otherwise the meter wouldn't be removable. So when these meters are installed, if there are any weak prongs, there's going to be a bad connection. Let's take a look at this prong here. There's some grease in there. You can see the spring tension, and let's take a look at this guy on the right. You can see it's slightly more open. That clip you see down in here, that's just a spring to make sure that maintains its strength. But over the years, especially in an area where there's lots of hot and cold temperatures, expanding and contraction of metals, maybe 50 years of meters being popped on and off, eventually those do get weak. What we as a company have been doing during our smart meter change out is they have to take a picture and send that off to our head office for every single install. Any connection that has the slightest, if there's the slightest concern to any of these connections, even though the homeowner owns this, our company is paying for the repairs to install a brand new one to ensure that there are no issues whatsoever and that heating from a bad connection to occur. So just to give you guys an example, I got this fancy little tool here and it has a spring on it. You can see that little red flag. So we're going to push that in, simulating the meter being installed. And it's not entering the jaw. That red flag is disappearing. So that's telling me that there is enough tension to make a proper connection when that meter is installed. So if we check all the lugs, we're all good to go. We get to this guy, and you can see that red, it's not fully disappearing. The connector actually did enter into the jaw without that red flag disappearing. So there's not enough tension on that jaw to have a proper connection for that 160 amps that this meter socket is rated for. Let's just take this locking ring off. So when we go to install that meter, it's going to lock in place. That meter is now installed, but I can assure you within a couple years at the most, maybe even within a couple days or weeks, if there's a ton of load, that 1 week connection, it'll probably fail. When that connection does fail, that's going to heat up. It's going to cause resistance. It's going to cause heat. That heat's going to transfer into the plastic. That's going to start melting. You will likely start seeing your lights flicker until that completely burns off. Another problem we encounter, this one here, that's all one piece, but a regular meter setup, the wires from your home go into a bolt-on connector in behind here. If that's loose, same thing's gonna happen. If it's a copper wire, there could be some oxidization with the difference of metals. The aluminum's a softer metal, so regardless if it's copper or aluminum, eventually over time, these connections onto the lugs will also fail. Then there's a matter of the block down in here, those plastic blocks on an actual meter socket, they're a bit larger. And again, with the hot and cold temperatures, maybe something banged up against the meter, lawnmower or something, those blocks sometimes do crack. When the meter is installed, your old meter, that block could be completely sheared off. There's no way to know about it. It's just sitting there floating, hooked onto the meter. But when we go to pull this meter off, that's going to come off the back of the socket. It's going to come right with the meter. It's broken. When that happens, it is the responsibility of the homeowner to replace this unit that they own. However, again, during this project that we are swapping out to smart meters, we're covering all damages during the change out. So really, if that was discovered when we change this meter and we're paying for the repairs, that's a good thing for you as a customer. So the majority, I just want to kind of sum this up, the majority of situations where, not even the majority, almost, I'm going to say all of the situations in my 21 years where I came across a meter that was smoking or there was arcing or fire, it's always because of a bad connection somewheres. It has nothing to do with what type of meter, whether it was a smart meter, an old analog meter, one of the RF meters. This has been a problem that has been ongoing since the beginning of my career and always will be ongoing. Stuff gets old, connections get weak. It's just a part of electronics lifespan. There have been some incidents with other manufacturers where one instance, for example, the meter wasn't watertight. This is a plastic cover on the meter, and the plastic is all one piece right up to this lip. That lip is then covered by this ring. So there's virtually no way rainwater can get in between this plastic and the meter itself. There was a manufacturer that there was water getting to the meter somehow. That was in Ontario. Again, conspiracy theories say, Ontario removed all their smart meters because of fires. No, there was 5,400 out of 4.8 million meters removed because of a very particular brand. There was no fires involved with that brand. It was discovered that water was getting in them, so that was preventative maintenance. There was another brand where there was a disconnect or something meter. I don't know a whole lot about that one. I believe it was in Saskatchewan where they were removed. This was back 10, 15 years ago. None of the smart meters being installed today are having any of those issues. So of course, if there's a fire and it starts, which usually doesn't result in a house fire. Usually you show up, maybe the siding's melted a little bit. It's because of a bad connection. Media gets a hold of that and blows it way out of proportion, saying the smart meter caused the fire. The smart meter did not cause the fire. In our province, I've never seen any issues whatsoever other than, like I said, bad connections. So to any lineman watching this video, be extremely diligent when you do change meters to inspect the inside of the meter socket. Make sure everything's in good shape before you install that. Also, see this tag here? These meters are federally regulated. If I get a meter on my truck and this seal is missing, basically it's looped through that plastic cover. If this seal is missing, I cannot install that meter, and they're extremely strict on that. We have audits where someone will show up right to our crews and go through their meters, go through their knowledge of all the checks they have to do. We can get in a lot of trouble if we install a meter that doesn't have that seal. And if that's the case, it's not something that we send back to our shop and the seal gets put on. That seal it's federally regulated and it's installed by the manufacturer, showing that this meter was tested and calibrated. I have never seen a meter fail in the way that it overbills. A long time ago with all the mechanical meters, eventually they slow down, but almost a negligible amount. They're not slowing down to the point where you're getting free power of any sort. You might be saving $1 a month or something like that. Electronics did slow down, but it wasn't an amount that was concerning to us as a company. And then the seal that you see on the ring, when we were looking at my meter outside, this ring gets sealed. That's just so we know that the customer didn't tamper with their meter or remove their meter to try to steal power or what have you. The second seal on this guy here, this is probably new to a lot of you. That's just to reset the demand for industrial customers that do get billed for their demand, which again, we will cover that at the end of the video. So that pretty well covers the fire, bad connection issues. The next thing I want to cover is high bills. I think you're going to find what we're going to do for a little experiment very interesting. Our company right now, it was a cold winter and there's an audit going on because we happen to install smart meters in some areas new this winter. People's bills went up and attributed that to the smart meters, which is not the case. But a quick Google search will show that not only neighboring provinces, but provinces across Canada, even into the US, you Google and it's like Newfoundland Power getting audited for improper billing. Nova Scotia, Quebec, like everyone's getting this third-party audit, but has nothing to do with improperly metered power. It's cold out. But we're gonna, like I said, we're gonna do an experiment here that's I think you'll find really interesting. All right, so I just had to run upstairs and grab this flare gun, which we're gonna use for our little experiment. I don't know if you can hear that humming going on, but that's my solar setup. Right now I'm generating 9,800 watts. So that's running my whole house off solar, which is awesome. Highly recommend. I've seen a few posts on social media where they did a lot of research into their usage. They showed the usage for particular days and months this year compared to last year, along with comparing temperatures, saying on this day last year it was minus 10 degrees Celsius. Today it was minus 10 degrees Celsius. I used more power today than last year. It doesn't make sense. But what they're not taking into consideration is the wind. Regardless of what the temperature is, wind drastically steals that heat from your home. Your house is like an extremely large heat sink where the heat dissipates into your walls, your roof, through the windows, and that wind blowing by your house, it's constantly stealing that heat. Pretty much the same as a radiator in a car. When your car gets to a certain temperature, fan comes on, it would surprise you how quickly that cools off, that coolant traveling through the radiator. Same as a heat sink on your laptop, for example. Little fan in your laptop blowing on that heat sink, that cools things off fast. And that's not air conditioned air, that's ambient temperature air. And that's what uses power, heat. Well, heat and AC, but majority of heat. Anything that's you plug in that draws heat, whether it's a toaster, a coffee maker, that uses a ton of power. You hear people say, I shut all the lights off in the house. Lights use a negligible amount of power, especially the LED ones nowadays. your toaster plugged in for 5 minutes is going to use more power than every single light on in your house over the next couple of hours. So to do this little experiment, we're going to use this flare gun, which is infrared, detects heat. It's extremely accurate. So just to show you guys how accurate this thing is, right now the screen's all blue because we're looking at the wall. As we look around the room, you can see it's picking up slightly different temperatures around different equipment. But this is cool. So the wall is 20 degrees Celsius. Let's take my finger and make one quick swipe. We can actually see that swipe. So my finger swiping on that wall heated up the wall by 0.5 degrees. And if friction causes heat, obviously, we're up to 22 degrees already on that wall. So a quick demonstration to show how much wind, air, that's not AC, that's just a fan, affects loss of heat. We're going to take this heat gun. We're going to start heating up the wall. Now I've got this Linework Buckets Products extendable clothespin that's really going to help us out here. I can for a second. All right, so that wall's heating up a lot already. Let's just take a look at the temperature, see how quickly that's heating things up. 76 degrees. Trying to get my target right in the center where it's the hottest. 85. $90 degrees. Looks like we're peaking around the 90 degrees Celsius mark. And we add a little bit of wind to that. Let's watch and see how quickly that's going to cool down. This is all going to be a straight shot, no editing. Just going to turn that fan on. Already down to 60 degrees. And we still have that exact same amount of heat blowing on that wall. And it's a fair distance away just from the battery operated fan. Down to 44 degrees. So this experiment is a little bit exaggerated because normally the wind's going to be on the other side of the wall. So you're not going to have such drastic numbers such as this, but it is a great example that you have a constant heat source regardless what type of heat you use. If it's electric heat that is heating up your home, see that should actually be burning my hand right now, but it's not at all. But you have a constant source of heat and it's fighting against the wind. When it's windy outside, which in eastern Canada, January, February, March, even now, every day there was 30, 40, 50 kilometer an hour winds every day. So the heat in your home, it's constantly fighting that wind. We're all the way down to 32 degrees. Now, let's watch again. The second we cut out that wind is gone. This thing keeps shutting off on me. We're already back up to 70 degrees. That's how quickly and how drastic wind can affect temperature. Especially on your windows. The heat loss through windows is pretty intense. And again, this is why a properly insulated home is so important. Power usage when it comes to heating your home in the winter, outside wind speed, even the amount of snow that's outside up against your home, it can drastically change the consumption of power and the heat loss around your home. One day can make easily a difference of $10 a day. You have wind all month. That's $300 in a month in extra power used just to heat your home. So just quickly before we go back upstairs, I want to show you guys, because I actually just built this yesterday. I went to my local Home Depot, bought all these racks and stuff. My room was getting pretty filled up with stuff. But Milwaukee sent me I don't know if these guys are available on the market yet, but these daisy chain chargers, you can charge up to 60 batteries off a 115 amp plug. It's pretty cool, especially when I'm doing yard work. I bought all the Milwaukee yard work equipment, and some of the equipment, it'll go through batteries pretty quick, but these daisy chain units, I've got it set up here, so I've got 12 batteries. Leave it on, set it on nighttime mode, leave it overnight, and it'll slowly charge every single battery I've got. These daisy chain battery chargers do fasten into this kind of setup with the wall rack, which is the same as, get a bit of a mess here, but on top of any of your pack outs. That's kind of why I've got them sitting up here at the top of that pack out. They're locked right in. So that unit is brand new. It is a rapid charger. It can charge all M18 batteries, including the new Forge batteries. This is what the cord looks like to set up your daisy chain from unit to unit. While I did purchase the majority of this stuff in this room, Milwaukee did send me these free of charge to try them out. They know I got a lot of their stuff. So big thanks to Milwaukee, and I will put a link to that in the description of the video. All right, so another conspiracy theory is the magnetic field, or the EMF or the RF that's emitted from smart meters. Oftentimes people say it's no different than a cell phone. Let's check it out. So we've got an EMF meter that detects both the magnetic field as well as the RF signals. And what I want to show you first of all, we've got my phone down here. So we're checking out the magnetic field on the phone. It's bouncing up and down a little bit. We're going to click on a video, and now that it's communicating with my modem, as it's buffering and downloading the video, every once in a while we're getting a quick jump up to 0.2, 0.4. But the real interesting one is my microwave. So check this out. All right, so you guys are gonna have to help me out with this one in the comment section, because I don't know a whole lot about reading magnetic fields or EMF. What the reading is, it says UT, but we're going to do just comparison between my microwave and the smart meter, and we'll do one continuous shot without editing so that it's 100% unbiased. But let's fire this guy up for a minute, and my meter's going off. The closer we get, yeah, we're at 29, 30. As we move away from the microwave, you can see it starting to go down quite drastically. And we get closer to the electronics. 39, 40, 49, 74. And the second we hit the stop button, it goes down to 0. So without touching anything on this device, let's go outside, try out the smart meter. So we hit what, 60 and whatever those units are on the microwave, and on the smart meter we're hitting 10 around the box, 6. So the peak amount of EMF, it's about 1/10 of that from the microwave. Let's check my solar disconnect just to see. Even the solar disconnect. So these magnetic fields, they're all around us with everyday equipment. I don't deny that there definitely are some people with sensitivities to this sort of thing, but if you're concerned about the magnetic field emitted from a smart meter, it's no different than many of the electronics in your home, especially your microwave. Interesting. So as I mentioned, you as a residential customer, you don't have to worry about demand, maybe for your own curiosity's sake, but how does that benefit us as a company to monitor that demand, and why do we want smart meters on there? So a couple of reasons I'm going to go through real quick. The smart meters actually do have a sensor that if there is a bad connection in behind the meter that we detected at the start of the video, it'll send an alarm to our head office saying that it's detecting heat. So we can respond to your house and find that bad connection before it gets to the point where you lose power or something does start smoking or heating up. We can identify and mitigate that problem before it becomes a problem. Second thing is, and this happens a lot, where you get a rural area 2 hours out of town, their power goes out. I show up for the no power call and they say they've been out for 24 hours, kind of wondering what took us so long. I didn't know their power was out. There's no way for us to tell. The customers have to call in, unless it's a huge drop off. If we lose 2,000-3,000 customers, we're going to notice that load drop off. And anything that's tied to a substation, that will send us an alarm. But single customer stuff that has a camp out in the middle of nowhere, when their power goes out, if you don't call, we don't know. With these new smart meters, when that meter drops off the system, we'll get an alert saying the power was shut off for one of two reasons: power outage, or someone's trying to tamper with the meter and removed it. Either way, we will respond without you even having to call. So probably the biggest benefit for a company with smart meters, you hear about time of day billing. And what that time of day billing is, this is going to be real formal, guys. I'm going to be drawing on a box on my new gym equipment thingamajig. So we're just going to draw a super cheap graph here, but you start at midnight, everyone's sleeping, your power usage, you're not using a whole lot of power. You wake up, have your shower, turn on your oven, that power usage is going up. You go to work, or even if you work from home, your shower's done, food's cooked, that power usage is going back down until supper time, at which point that power is going up again until you go to sleep at night. And the gist of things, your power usage, there's going to be peaks. So you take this really horrible graph I just made times 400,000 homes that we're supplying power for in our province, those peaks add up. So when we're generating power, everybody's peak, it's all compounding. We need to generate a whole lot of power to supply everyone in the province at breakfast time, at dinner time, at supper time. And on top of that, that stuff's unavoidable. You're going to eat dinner at dinner. But if everyone starts drying their clothes and cranking up their heating house, that's all going to add up onto that peak. So with smart meters, not only does it record power used, but you can program into it different rates depending on the time of day. So if we have a rate, which, by the way, guys, the rate for power in our province is cheaper than most other areas. So this whole power is expensive. Yeah, it is, but it could be much, much worse. I'm glad our rate is currently where it's at with this province. During these peak times, let's say this is 6 a.m. to 9 a.m., for example. If power is more expensive during this time, people aren't going to want to use their dryer. When they go to bed at night, let's say this is 8 p.m. off peak hours, if everyone starts turning on their dryer to do their clothes, do their dishwasher, maybe crank up the heat a little bit, there's going to be more power usage on our grid here all of a sudden, and it's going to cut this peak down. So what we're hoping for, instead of power usage across the province looking like this, we're hoping to have something more a little bit like this. Why is that important? Because our generating capabilities, let's say this is the peak amount of power we can generate. There's times a day where, and we're not that close, we're more like up here. But with growth, it is a concern. So if we're hitting a constant peak that's getting close to our maximum amount of power we can produce, buying power from neighboring provinces is expensive. If we can alter people's habits to use heating elements such as dryers at off-peak times a day, and reduce that power usage to try to get a straighter line. We don't have to worry about overbuilding the system just for those few times a day where we're hitting that peak. But horrible graph, you get the idea. Anyways, like I said, I debated, I'm not even sure if I'm gonna post this video or not. There's a lot of talk about smart meters, but the misinformation online that's coming up from John sitting in his basement that has zero education on electrical systems, that's reading websites that have conspiracy. Anyways, don't fall into that, guys. I did notice that on a video a while back, a fellow that actually worked at the manufacturing facilities for smart meters commented on one of my videos and presented some real good facts. This video wasn't overly technical, just a general explanation as to some of the customer complaints we're getting, but I definitely encourage some conversation in the comments. That's like no fighting and bickering, guys, but educated concerns, questions. Feel free to answer other people's concerns, especially if you have a more in-depth knowledge on this subject. Anyways, I'm gonna post this, see what happens. Thanks for stopping in. As always, in our next video, it'll be up in the air doing line work, I promise.